Let me show you how to be a good Bayesian.
If you've ever wondered how Bayesian optimization makes its way from research papers into real-world systems at scale, this episode is for you. Today, I'm joined by Max Balandat, Research Scientist Manager at Meta, where he leads the modeling and optimization team and oversees the development and application of BoTorch, a flexible open source library for Bayesian optimization built on top of PyTorch. We talk about the challenges of building tools that need to serve both experimental ideas and production scale systems, and the role of open source culture in making that possible. We also dig into how Meta approaches scalability, the importance of communicating uncertainty to stakeholders, and what he's learned about bridging the gap between academia and industry. Looking forward, Max reflects on the potential of integrated large language models into optimization workflows, why community contributions are vital to BoTorch's future, and the broader lessons of bringing research into practice. This was a fascinating deep dive into the intersection of open source, Bayesian optimization, and applied machine learning. And I think you will really enjoy it. This is Learning Bayesian Statistics, episode 139, recorded July 10, 2025.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence.
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is the place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. And if today's discussion sparked ideas for your business, well, our team at PyMC Labs can help bring them to life. Check us out at pymc-labs.com. Max Balandat, welcome to Learning Bayesian Statistics.
Thank you, Alex. Happy to be here.
Yeah, I'm super happy to have you on because I've had a couple of recommendations to have you on the show, and also because, BoTorch looks amazing. So I'm really happy to talk about it with you today and dive a bit into that and optimization, which is a big topic in the statistical world and in the Bayesian world in particular. But I don't have a lot of episodes about exactly that so far, so I think it's a good time to do it, especially since BoTorch makes that way easier for people to do that. So we'll talk about all of that, but first, as usual, your origin story, because you grew up in Germany. You began studying electrical engineering in Darmstadt, and then you moved to UC Berkeley for a PhD. So I'm curious, basically, why you're doing what you're doing nowadays, because it wasn't obvious. And so, yeah, basically, what first pulled you towards probabilistic modeling and optimization?
Yeah, it's a little bit of a meandering route, I guess. So I started electrical, as you said, and I actually had like a bunch of mechatronics, so mechanical engineering ingredients, so like fluid dynamics and all kinds of things. I then got interested in control theory and got excited by that. Was actually in Berkeley on exchange for a while and learned a lot about optimization there, convex optimization, other optimization. Actually took a break and did some management consulting, went back to Berkeley, did more control theory, but then I was, like this econ stuff sounds interesting too. I did a lot of like functional analysis and math. I got interested in power systems, so going from like very kind of like theoretical to like very applied, empirical econ, causal inference. So all of these things involve, optimization. But I never really like went deep into kind of like the Bayesian aspect of it. It was actually like after I joined Meta full time, when I was working with my now boss Eitan and Ben Leatham who were starting off black box optimization at the time, and so I kind of joined the bandwagon and kind of learned on the job, if you will.
Okay, so that was a bit I was a bit late in the game. Okay, I understand. And
Yeah.
so yeah, go ahead.
No, it was kind of late in the game. I had the background from like probability theory and some statistics from my PhD. It wasn't that far away from that, but the actual kind of like going into Bayesian statistics and Bayesian optimization happened at work, if you will.
Right. Yeah. So we'll dive into that because I'm guessing there are some practical considerations and motivations that drew you to that. But to rewind a bit, after you finished your PhD, you joined Meta, which I think was still Facebook's.
It was Facebook, yeah, exactly.
Yeah. So the Central Applied Science Group, and now you manage the sub team, which is the modeling and optimization team at Meta. So first, I'm wondering what drew you to industry when getting out of a PhD, and also how has your role evolved at Meta, because you've been there for a few years now.
Yeah, quite a while now. It's coming up on 9 years, if I don't count my internship, and that's kind of like also the entry point. So it was a little bit. It wasn't always the plan. So I was doing my PhD, and I was initially pretty sure I wanted to be an academic. Because I guess that's maybe even the default in some sense if you do a PhD. I told you a little bit about kind of like my sort of meandering route in different like fields, and I did a lot of, I wouldn't say eclectic things, but different things during my PhD, and that was great. So I had a lot of freedom to explore this, but it's not exactly like the best portfolio to have when applying for a faculty job. So I didn't really want to go and do a postdoc to build up more of a portfolio there. And I actually did an internship at Facebook during my PhD at Berkeley. And that was super exciting. It was a super cool environment. Lots of smart people did work on some large scale data and large scale infra. And so that was, exciting and new. And I ended up getting a full-time offer after that internship. Went back to finish my PhD, and it wasn't really a hard choice to say yes at the time. And I guess I've, stuck with that since. So that's how I ended up at Facebook or Meta. And what drew me to the research is, I guess it's much closer to the application, right? Like, in grad school, you'll always like, oh, what problem should I think of for my next paper, right? But in industry, it's like, we have a problem, like, how do we solve it? And so that is, much more direct in terms of how the research can create impact. And so the path, especially if you're in a technology company, the things you do can affect production pretty quickly. And that's the exciting part about that research work. In terms of how the role has evolved, I started out as I guess we were called data science at the time. So as a data scientist, and I pretty quickly went into kind of like the Bayesian optimization direction. And initially it was just a lot of like development, trying out things, coding up some ideas for BoTorch. I did transition to a management role a few years after, and initially with a smaller team, and now my team is a little bit bigger, and so the role has changed in the sense that it's much less kind of like long hours of focus time thinking about a statistical problem in depth. I'll try to make room for those as well, but there's a lot of kind of like organizational, people management, project management aspects to it. So it's more of like overseeing a research group than it is really digging into one specific problem.
Okay, yeah. And what does that look like actually now that you manage this group? I'm curious if there is a typical day for you, or if it always changes on the fly.
I don't say it's a typical day per se. I have a decent amount of meetings checking in with all the folks on the team about what they're working on, coordinating, and there's a decent amount of work outside the team, right? Like we're sitting basically in sort of like horizontal position, central applied science. We work a lot with different product groups and teams at the company. both on the more researchy side and also on like the applied and product side. And so there's a good amount of kind of like cross-functional coordination, lots of meetings with lots of folks across the company and building those relationships to understand, where are the big problems that we can work on and where sort of like, the highest ROI kind of like investments that we can make with our applied research to drive value for the company.
Okay. Yeah. Yeah, I'm almost curious to understand, what the management positions look like in different environments, and the modeler in me always wants to see if there are some interesting patterns.
Yeah, I mean, I'm still trying to be technical, right? Like I'm still trying to carve out enough time to do coding or, go deep on some papers or, help write papers. But, it's not always easy to find a lot of time for that, but I'll try to,
Yeah.
do that.
Yeah. I completely understand that. So actually now let's talk about some technical stuff, because I'm
Sure.
I'm really curious about BoTorch.
Yeah.
So everything will be in the show notes for people to dig deeper, but yeah, can you give us the elevator pitch first? Well, what is what is BoTorch? What does it solve for users, and when should they use it?
Yeah. So I guess how familiar are people with Bayesian optimization? Would it make sense to give like a little primer on this, or can we assume that folks,
So
understand?
yeah, you can assume folks are really familiar with Bayesian models and posterior distributions, and then basically, you can give a short primer about, okay, we have a distribution, now we want to make a decision. Why would we do this kind of decision optimization?
Sure, yeah. I mean, so the way, really in a nutshell, it works is, right, you have some black box function you're trying to optimize. It's really expensive to evaluate. The way to do it, you build a probabilistic surrogate model to understand how the function behaves, but also importantly with uncertainty quantification, so you know what you don't know, right? And then in Bayesian optimization, you typically put an acquisition function on top of that probabilistic model, which essentially helps you trade off exploration versus exploitation. And then you optimize that to generate a new point to sample. You evaluate that on the black box function, put it into your model, refit the model, and continue. So that's kind of like the nutshell version. What what BoTorch does, BoTorch is Bayesian optimization PyTorch, so obviously it's a library for Bayesian optimization. It's more specifically if you want to do research on Bayesian optimization, or if you want a high degree of flexibility and you know your stuff, so you don't start shooting yourself in the foot by trying to apply concepts that you don't really understand. So I do want to issue a warning here that it's not necessarily a good choice for people who don't know much about Bayesian optimization and just want to use it as a way for black box optimization and don't want to really worry about the nitty-gritty details, such as like models and model fitting, acquisition functions, and so on. So for that, we actually have a separate tool called Axe. It's a platform for adaptive experimentation. It was actually co-released with BoTorch back in the day. This one's more user-friendly, has higher level interfaces that remove a lot of the complexities from having to assemble your problem in BoTorch, so like by hand. And we actually did finally write a paper about it after many, many years. It'll be in the AutoML conference in New York in September. So you can read up more on that. But back to BoTorch. So basically like two use cases. Like use case one is if you're a researcher and you want to develop new Bayesian optimization algorithms. So BoTorch, has a lot of foundational or, fundamental abstractions that you can easily subclass, extend to do new things. So, for instance, you can use a different kinds of probabilistic surrogate model. The defaults are Gaussian processes, but we and many others have tried other types of models, such as, Bayesian neural nets, private networks, and various other things. The nice design feature that BoTorch has, it uses Monte Carlo acquisition functions. So basically, you just need to be able to sample from the model's posterior, ideally in a differentiable fashion. So basically, what this enables you to do is move very quickly in trying out new things from the research side. You don't have to fight with kind of like a complex, framework where you don't necessarily know what's going on, but it's really intended to be modular, so you can like dig in and really change the details of individual components. And that's a key reason why it's been quite popular in the research community. If you look at some stats of like what some of the top tier conferences are using, I've done some assessment of that recently, and I thought that about like 2/3 of Bayesian papers in NeuroPsyCML AI stats are using BoTorch, which is great to see. And so that's like the research side. There's the use case number 2, which is basically you're not necessarily a researcher, but you still want like a high degree of flexibility of how to use Bayesian optimization. And so the modular setup that BoTorch follows allows you to do a lot of like custom things, custom data processing, transformations, custom optimization algorithms, the whole orchestration around the optimization loop, that are very hard to make easy in a more opinionated like end-to-end framework that is like less removed from the details. So there's like a sizable group of folks who work on Bayesian optimization for material design, chemical design, protein design. These are problems with like non-standard search spaces. So rather than like optimizing over some subset of Euclidean space, you optimize over say the space of molecules. And it's very hard to write a high-level interface for something that can do all of this, and the same thing for materials and so on. So BoTorch allows you to do that, with some additional handling that you have to write yourself. And I guess like the other thing is, a selling point here. It's an open source package, so unique value proposition maybe the better term. The unique value proposition is that everything's written in PyTorch in a fully differentiable fashion. So whatever PyTorch module you want to stick into it, you can integrate into BoTorch. So common thing might be you have some encoder of some structured input into a latent space or some kind of feature extractor, and you want to stick that into a modeling setup for Bayesian optimization. And in BoTorch, since everything's written in PyTorch and is differentiable, you can just stick it in there. You can use that as a pre-trained embedding. You can train it jointly with a surrogate model, whatever floats your boat. So it just offers a lot of flexibility, especially since you can find a lot of high quality PyTorch implementations that are out there for basically anything that you want to do.
Yeah. This is really interesting, and I've looked at the website, of course, for BoTorch to prepare the episode, and now I wanna find a use case, to try that up. Because that looks really cool, and also I really like the API for users. It looks very well integrated with PyTorch, as you were saying. One thing I'm curious though is, so yeah, if you fit your model on PyTorch and then when I optimize with BoTorch, it's going to be super easy. What if you used a PyMC model, for instance, and then you get a posterior distribution? Can you just come with your posterior samples and plug that into BoTorch, or would that work differently?
Yeah, it's a good question. So basically, we assume that our inputs are torch tensors. Of course, you could use PyMC or any other thing to convert it to a tensor and stick it in. I think what you'll lose is the differentiability and the end-to-end kind of like autograd that you could compute on this. But if you do have a model and you can sample from the posterior distribution conditional on like whatever input you stick in, then you could take those samples and put them into an acquisition function. I think there would be a little bit of manual work to make this work, but the fundamental setup of the MC acquisition functions will allow you to kind of like compute things like Monte Carlo EI or whatever other version there is using that. Now, the thing that you lose that is one of the nice things that we have in BoTorch is, since you can't differentiate through those samples, something we do with the reparameterization trick in BoTorch, you'd have to like optimize that acquisition function without having access to gradients, right? So you basically have to do like a zeroth order optimization over the acquisition function, which is fine if you're in low dimensions, but if you have a complex and high dimensional problem, that can be hard to optimize, because gradient-based methods are just much better in these higher dimensional spaces. I mean, that's how we fit neural nets, right? So yeah, I think it will generally work, will require a little bit of adaptation, but you're losing some nice features.
Okay, yeah, so you recommend mainly, like, the easiest case for people to at least get a feel of how that works would be to have a PyTorch model and then use BoTorch on top of that.
That's right. I mean, I should say that, BoTorch also comes with like models, packaged in, right? Like, it's not that you have to like bring your own model. So we have a bunch of high quality implementations of Gaussian processes, and there's a couple of other examples on other models on our community setup. And so you can use those out of the box, right? If you don't want to like go deep into the modeling, you can use that. So there's enough stuff there to like just assemble an optimization loop that will generally work pretty well without you like having to bring your own. I think the thing you need to do around it is like the orchestration. But I guess with the flexibility that you have is you can bring your own model, or you can bring your own like acquisition function implementation.
Mm-hmm. Okay, yeah, and actually this is a perfect segue for me to ask you a question I had planned also, which is you built BoTorch on top of PyTorch and, as you alluded to, GPyTorch, which again is amazing, and it's going to be in the show notes. And listeners know I have a very close history with GPs, and I love them, so GPyTorch, definitely appreciate that. HSGPs also have changed my life. Now you can use GPs for much more, many more models, and many more use cases without waiting for hours for them to sample. So it's really absolutely incredible. I use them a lot in PyMC to have modular models, so not only GPs, but you can build other parts of the model with non-GPs part, and then you can use the GPs for nonlinear parts. And HSGPs really have changed the game on that, because you can also make them hierarchical. So that's really awesome. As soon as I see something with GPs in there, I get curious. So thanks so much for GPyTorch, and also for adding that in BoTorch. But I'm wondering, why was that interesting for you as the developers to build that on top of PyTorch and GPyTorch? Like, what advantages, and also I'm guessing what headaches came from building on top of a deep learning stack instead of writing a bespoke framework. And if you hear some barks, folks, that's not Max, that's Max's dog. That's here on the picture. If you're on YouTube, you can probably see him or her. Beautiful dog, Max.
This is Keola. I mean, his sister Kaiko is outside, and she's working up a storm, and he's just being supportive. So sorry about the noise, but they're quite energetic and vocal.
Yeah, that's perfect. I mean, that's the charm of live recording a podcast. So welcome to the show. So yeah, if you wanna, did you get my question about?
I did get your question. Yes. So
okay.
So I mean, I really wanted to have a differentiable programming basis, right? Like, I wanted to be able to use auto differentiation, because I've spent a lot of time writing gradients by hand in like a previous stack, and it was kind of like a pain, as most people can imagine. And so I really wanted that. And I also really didn't want to like implement AutoGrad from scratch. So it was basically, PyTorch was an obvious core foundation for this. TensorFlow could have been as well. I guess this is a while ago, so JAX actually really didn't exist yet then. But PyTorch was in-house at Facebook, right? So we worked pretty closely with some of the PyTorch folks to actually also release BoTorch. I mean, we're part of the PyTorch ecosystem and in the PyTorch GitHub org. So it was basically just, hey, I needed like differential programming. Who has a cool framework for that? Oh, they're not sitting too far away from me. I should talk to those guys. And so that's basically how it started. And by the way, I do take full credit for for PyTorch winning like the AI framework wars. Just BoTorch did that for them. No, just kidding. But so that's like the PyTorch part. And then as to GPyTorch, Gaussian processes are kind of like the go-to model that you'd use for Bayesian optimization. I mean, there's lots of alternatives around. Some of them I mentioned that cover certain use cases, but certainly at the time, kind of like GPs were it, and for the majority of use cases, we still use them today. So I basically needed like GPs built on PyTorch, and that made GPyTorch a pretty obvious choice. And so at the time there was like an alpha version out there. I reached out to the developers, Jake and Jeff. So shout out to those guys. And we worked together on figuring out like how can we make this work for Bayesian optimization. That was kind of like the genesis of why PyTorch and GPyTorch are kind of like the foundations for BoTorch. But again, it's the PyTorch part is kind of pretty deeply integrated, so it's sort of like not that easy to use it without PyTorch. But the modeling abstractions that we have do not require you to use GPyTorch, right? So if you have, a Bayesian neural net or something else that you want to use, you can stick that in.
Yeah, this is super cool because like if you can experiment with some GP models easily out of the box with BoTorch, like this from a user perspective, that's really easy, and I really like that because I have kind of a similar background to yours, which is where like I've been working in industry for years, and also I'm an open source developer, so you focus a lot on the consumers of your code. And it's like, okay, well, we have that problem to solve, but the goal is not to write a paper. The goal is to actually solve the problem and make it possible for people to use your solution. So thankfully, more and more papers now in the academic side, they come paired with an open source, at least open source repository, and more with a corresponding Python package that you can use and reproduce the analysis, which is great, because otherwise most of the time people can't use what's in the paper. But yeah, like often my bias is very much on, okay, but how are people who don't really know all the nuts and bolts of that problem going to be using that? And so yeah, as you were saying, GPs are so versatile and really good also most of the time at predictions that if you can make that easier for people to use, that's really a huge bonus in my eyes. Actually, a bonus question for you on that is, when would you recommend people use GPyTorch, for instance, like independently of BoTorch? Like, what kind of problems would you say GPyTorch is really excellent at, and what types of problem would you say maybe here it's not going to work that well, or maybe here it's an overkill?
Yeah, that's a good question. I mean, I think GPyTorch has a similar design philosophy as BoTorch, and I guess and PyTorch for that matter. And that is kind of like also being so like research focused and allowing people to like easily subclass and extend and use their own. So certainly if you want to do that, it's a great framework for doing that. If you just want to fit a standard kind of like GP with like a matern kernel and like, uninformative priors on some data, and you want that to be fast and you don't want to have to deal with other things and overhead, you don't necessarily need to use GPyTorch. GPyTorch provides you a lot more flexibility. I think the thing that GPyTorch was built around initially by Jake and Jeff was using kind of like iterative linear algebra methods, so like Krylov subspace methods. So linear conjugate gradient solves rather than using a Koleski decomposition to compute to solve kind of like the GP equations. And so whenever you have like structured matrices, whenever you want to run things on a lot of data on the GPU, that is kind of like one aspect. And of course, since then there's been a lot of stochastic variational GPUs and other kind of like sparse GPU methods that have been integrated there. So there's a decent amount of like recent research work that also finds its way into GPyTorch on GPs. So I think those are the cases again where GPyTorch is a great package. I will say there's like some overhead in how the internals are being written that kind of like are necessary to handle, structured matrix representations. And so that overhead, if you just work with like in the very small data regime, with pretty little data, like 50, 100 data points or something, and everything's just like dense matrix, and everything's fast just by running it on optimized kind of like Koleski methods and so on. Then there's overhead, right? Like it's not going to be necessarily as fast. So it's a little caveat, but in general, I think it's a great library.
Yeah, completely seconded. And how does it work for, priors? Like, can you use, because you were mentioning many uninformative priors, can you make the models more informative in GPyTorch if you want, if you have good priors? Because I know that can be very, very important for GPs to be able to sample well. And also, can you combine any GP parts of the model with any non-GP parts?
Yeah, so I guess priors, there's the prior in the sense of like the prior over the hyperparameters. And then there's kind of like basically the GP priors, right, the kernel and the hyperparameters. So if you want to, depending on whether you do a map estimate or like a fully Bayesian implementation, it's pretty easy to stick in, different priors over, say, like the length scales or other aspects. So that is reasonably modular as well, so you can pretty easily do that. I do have to say I missed the second part of the question again because my guys have been barking again here.
So that was the prior part, and as you were saying, I was referring to mainly the hyperparameters of the GP. So let's say you have a matter and kernel, as you were saying, so that would be the length scale and the amplitude, and most of the time it's, especially if you want a full Bayesian estimation of that, you really want some prior information in those, because they are like, let's say, like weakly unidentified in the model most of the time. And the second part of my question was, can you combine model parts in GPyTorch? Like you have a GP and then the other part of the model is something else, like a classic linear regression or something like that, where you add an external covariate.
Yeah, no, for sure. And it's in the same sense, done in a very modular fashion, similar to BoTorch. And so, if you do want to stick that, neural network feature extractor on top of your GP and put it in there, you can. Yeah. So, very much working in the same kind of like fashion as BoTorch, modular design. You stick it in, and then differentiability and autograd will help you, and then you can do things. You can like jointly fit. So like a classic example would be like deep kernel regression essentially, or deep kernel learning, I guess is the term, where you have some neural network feature extractor and you basically like put a GP on the features. So it's very easy to do that. You can kind of like use a pre-trained feature extractor and then only fit the GP hyperparameters. Or you could like do some fine tuning with both. So it provides a lot of flexibility, similar to BoTorch.
Yeah, this is really cool. And by neural network feature extractor here, are you referring to, for what I understand from that, but you tell me if I'm wrong, is you have a lot of features, you don't really know how they relate to each other, so then you first fit a neural network on that to understand basically how the features relate to each other and maybe if some of them are redundant. And then once you have that subspace, you only feed the GP on that subspace of the features?
Yeah, basically. I mean, I guess the question is it like a supervised or so like an unsupervised type of embedding? But ultimately, like you have some high dimensional space, right? You want to embed it in a low dimensional Euclidean space so that you can like easily put a GP on top of it. So that's what I mean by that. And like you can either just jointly train this, but you'll need a decent amount of data, and there's some, difficulties around that. Or you can, what we see often in cases where people are using things like molecular design or protein design, they'll kind of like have a lot of data, do some maybe like a variational autoencoder or something, right, where they basically have some latent space that they can kind of like train without necessarily the GP component. And then once you have that mapping from like this high dimensional descriptor space of what it is down to a latent space, and then you stick like in a GP model on top of that. So in this case, you'd be like doing the pre-training of that embedding, and then you're using that as a tool and to basically take this high dimensional input, stick it into the low dimensional space, and then work on the GP on top of that.
Right. Yeah. Okay. Yeah. That makes sense. Yeah, because you want to reduce the dimensionality as much as you can before fitting that. Before fitting the GP. Yeah. So that makes sense. Okay. Yeah. And actually, let me ask you the same question with PyTorch. So we've seen in which cases GPyTorch is very interesting, but we haven't talked a lot about PyTorch actually on the show. So even though it's a huge package in the Python ecosystem, it's more tangentially linked to the Bayesian framework. So I think it's a great occasion also to tell listeners here, well, in which cases would they want to give PyTorch a try?
Well, I mean, PyTorch is a generic kind of like deep learning framework, right? And it basically, again, has like the components to assemble neural networks and various other kind of like deep learning models. So I guess any kind of like modern machine learning that you'd want to do, be it kind of like fancy GPs or just like large scale neural networks, certainly obviously transformers and various other things. So really like a Swiss Army knife of any kind of like ML or deep learning aspect. I do want to say that like PyTorch provides like the core probing framework, and you can build on top of that. I do think that like in terms of like probabilities and support for that, I do think that PyTorch is maybe not as strong as say like something like JAX is these days, just because it hasn't necessarily been the focus, right? Like
what do you mean by probabilities here? Do you mean distributions?
Yeah, distributions and kind of like just functionality for computing various KL divergences and so on. I mean, PyTorch does have those features, but it feels like these are kind of like more well supported on the JAX side. And I think that's partially just because PyTorch, because I think the audience for like the standard deep learning, let's fit like a large neural net on like a whole bunch of data, is just much larger than kind of like say like the Bayesian machine learning community. And so I think it's just like a matter of priorities. But yeah, so basically, like in a nutshell, basically like PyTorch, if you want to do really any kind of like modern deep learning, it's sort of like a foundational programming language for that. And then you can go out and like have a gazillion packages built on top of it for particular applications, GPyTorch and BoTorch being one of them or two of them.
Yeah, exactly. So folks, basically, if you want to try a neural network, PyTorch is definitely a great way to go. And then if you want to combine GPs with neural networks, as we just talked about before, you can definitely give GPyTorch a try. And yeah, I can confirm that this can be very, very powerful combination. It really depends on the use case, also on how interpretable you want your models to be, on how big the data are. So it depends on a lot of things. But I think if you are in such a use case, this is definitely a very powerful combination. And actually, I wanted to ask you also, like concretely, if we come back to BoTorch, how did that come up at Meta? Like, what concrete problem, if any, inside Meta triggered the first commit to BoTorch, and also how did you make the case to open source it? Because that's really awesome, and of course I'm very sensitive to that, but I know it's not always the case.
Yeah, so I mean, BoTorch really was born out of the need to have more flexibility to enable our research and accelerate our research. So we were doing Bayesian optimization before BoTorch. We had a different stack. At the time, we were leveraging GPy, which is another GP library, and had some custom optimization code that was built on top of that. And that worked fine for like the basic problems and just fitting a model and doing Bayesian optimization. But it was really hard to try out new ideas. We had to work around the limitations of the setup to do custom things, like even simpler ones, right? Kind of like trying a non-standard kernel or like using a different like optimization strategy. It wasn't using differential programming, so again had to implement gradients by hands if you wanted to do anything. It was just like very slow to iterate on the R&D that we wanted to do. So basically that was the state. We were doing Bayesian optimization for things internally, and it was kind of like a pain to make the research progress. And so I started a bit of a side project at the time, and I was looking into how you could resolve that issue. PyTorch was around then, but it was still the relatively early days. So we're talking, this is early 2017. I think the first PyTorch release was like, I don't know, 2016 or something. PyTorch was a meta project, that I mentioned that before, and so it's very natural to look into it. I had found those initial alpha versions of GPyTorch that I messed around with that seemed promising. Reached out to the authors, and we had some great discussions. And it seems like it was a good fit. And so after some time, I put together some proof of concept, and it pretty quickly became clear that like we had something interesting there, right? It was just so much easier to try out new research ideas, given the modularity that I mentioned earlier. And this is like when we knew that we wanted to put some more effort in it, adopt it for our use internally, and then also open source it. And why open source it and how to make the case, I guess. Well, fortunately, Meta has a great open source culture. I mean, there's many examples for that, right? There's like PyTorch, obviously, more recently Llama, of course, but there's a lot of other stuff as well, like React Native, Presto, all kinds of like great open source packages. So the whole culture it was just conducive to this, and the culture on the team, on the Narrower team, like aligned as well. So my team had done some open source releases before. For instance, you might be familiar with Profit for time series forecasting. This is something that Ben on our team had done prior to BoTorch. And so anyway, it was like quite an easy environment to get leadership support and also like get through the necessary legal reviews. And yeah, so that was kind of like how we got the buy-in. And fortunately, we were also able to like work closely with the PyTorch folks on shepherding BoTorch into open source. I mentioned it's part of the PyTorch ecosystem, part of the PyTorch GitHub org, and shout out to Sumit and Joe, who we worked with at the time, to get this out and have their support for that.
Yeah, this is really fantastic, and thank you so much, guys, for doing all this. I think it's really awesome to see these, being useful to you guys at Meta, but not only to you guys, but you share that with the whole community, and I think it's fantastic. And yeah, also like I guess you also benefit from that in the sense that hopefully that brings you some new contributors and maybe ideas that weren't around inside Meta and that maybe made the package even better.
Yeah, for sure. I mean, that's a big part, right? Like it's a big part of like why we want to open source things, and we do get a lot of great bug reports and community feedback, and some people fix bugs for us, which is great. It's actually like also been like great for hiring. I've had a few people on the team who initially I came across, they were committing to BoTorch and they did some interesting research and like, these guys know what they're doing, and one thing led to the other, and that in turn and eventually become and work on the team. So it's been great for that purpose as well. And yeah, I mean, it's also just really gratifying to see how it's being used externally for things that we don't necessarily work on, right? Like we have a pretty broad range of things we do internally, but we at Meta, we don't do, cancer research, or we don't do, nuclear fusion simulation, these sort of things, right? But people externally do, and sometimes we actually get to collaborate with them, which is great.
Yeah, I mean, you're preaching to the choir here, but that's great to hear, and hopefully we're helping some people get some arguments to tell inside their organization that they should open source some project, because it's not only good for the company, but it's good for hiring and marketing also, I guess. That also puts the company out there as a company that does fun stuff at the frontier, and that's also contributing to the community. So, and I think these are very attractive features, at least to me. But I can guarantee that I'm not the only one, because this is a nerd podcast, so there is a lot of us out there.
Yeah.
And something I was obviously very curious when I prepared for the show and I exchanged with you beforehand was, how did you make that scale at Meta's scale? Because sure, it's hard enough already to have a package that works and that you use to develop prototype notebooks. It's a whole of another thing to handle the trillions, I'm guessing, of internal requests that you get at Meta. So, how did you pull that off? And also, in particular, like, which design changes, if any, proved pivotal?
Yeah, it's a good question. So I guess fortunately we don't quite, or we as in like BoTorch and Axe and like the Bayesian optimization part of like the things we do, we don't quite serve like trillions of internal requests directly. We work typically on much higher aggregation of the data, but it's still a lot, and there's still a lot of usage, and so scalability is definitely a consideration. And there's, I guess, two aspects of scalability that I would think here. So one is just the number of observations for a single Bayesian problem. Often they're rather small, but like we do have some larger scale use cases, some cool use cases that involve hundreds of thousands of observations, maybe for a particular optimization, which is very large for Bayesian optimization standards. There we'll have methods that are specifically designed for that. You use some kind of other model like a SVGP or something, where you can do mini batch training, or some other strategies. For instance, Turbo, Trust Region BO is work that David Erickson on my team had done before he actually joined the team. So that we can do without too much trouble, given the modularity of BoTorch. And I think the other scalability aspect is, like how many of these problems are we actually solving, and like it needs to be so like robust, people rely on it, and it's get deployed across different systems, and there's a lot of like code changes. So I think there it just gets back to really fundamental good old software engineering best practices, right? So having an efficient implementation, having lots of testing, unit testing, integration testing, nightly benchmarks to catch regressions and so on, rigorous code review, and then piggybacking on the internal meta infrastructure, having on-call rotations to cover things in case of breakages that might occur, and so forth. So yeah, I think that's kind of like a more standard like software engineering aspect. But each individual problem in its own often is reasonably small, just because that's typically what happens in the Bayesian optimization setting.
Okay. Yeah, so basically aggregate the data. That helps a lot.
Yeah, I mean, I guess like you could try to fit some SVGP on trillions of data points, but yeah, it's just you'd be fighting a lot of infrastructure battles, and you can often make do and be much more effective and have much higher ROI if you do some kind of aggregation. A lot of those aggregations are often being done by other teams.
Yeah. No, that makes total sense, and that's also something I see on my work, where I work with baseball data, and now we have pitch level data, and do you always want to use data at the pitch level? Not necessarily. Depends on what you're doing, and if you do always use at that level of granularity, you really have millions of data points, but maybe you don't need that level of granularity for what you're studying, and then you're just making your life much more complicated because fitting the model and just using the data is going to be way harder and longer.
Yeah, I mean, I think it's also, I think, a matter of like breadth versus depth, right? Like, if you're focusing on like one very specific problem, you can, you should do the thing that it takes to get this done, right? And if it's like, oh, we're going to fit like a large scale model and a lot of like granular data, then that's what you should do. I think from our perspective as a team that provides internal tooling that ideally is generically useful across big parts of the company, in order to get to that point, we need to like have, we can't go like super deep on every single problem. We do go deep on some problems, and we have this collaborative scale model we call it, where some research scientist will go in and work pretty closely with a team facing a particularly important, particularly high profile or crucial problem, and then develop some methodological like improvements on that we can then upstream back into the work. But there's a decent amount of just kind of like product work to make Bayesian optimization just useful for a broader sense of like ML engineers, right? And there's a lot of questions of, oh, what does a good UX look like? Are there like UI integrations that make that easy? And so with that, you can kind of like just cover a lot more space. And the nice thing about Bayesian optimization is it is a pretty generic formulation. Like there's a lot of cases where people have things they want to optimize. And so, that kind of like framing, that abstraction makes it applicable across like a really whole host of things. And so that's what the work we're doing, and kind of like taking a step away from like the specifics of the problem. And in that case, you just have to work with somewhat more aggregate data, because otherwise the heterogeneity in the data is just going to make it really hard to have something that scales out across problems.
Yeah. And also, I'm curious, are you the ones, so you're the ones developing these, these packages, these solutions like BoTorch or PyTorch? Are you then the ones who use them internally to define the models and run the models? Or is your job mainly to develop the packages and then you ship that, and other teams inside Meta are tasked with using them?
Yeah, so probably the latter, right? Like, there's a lot of ML and modeling going on. So if you're thinking about the deep learning models that are powering our recommendation systems, for instance, right? There's whole teams of like ML engineers, like more classically, like say deep learning trained, who work on those. And so our role and the role of like the PyTorch team is to like build PyTorch and make that usable, and generally like I think the ML setup is like commoditized enough at this point that they don't necessarily have to work super closely with the specific product team on like any particular kind of like model. So they're somewhat separate, and then there's like intermediate teams in between that are more kind of like application focused, right? Like that are technically working on PyTorch, but are like focused on, I would say, application engineering. To test out like maybe new features and make sure that the stuff that's getting built into PyTorch really helps the kind of like particularly the hard problem or scalability issue that the product team is facing. From our perspective, right, like we sit a step behind that, so we do work directly with people who are building those models. But typically, what we do is not go into like the their deep learning architecture in depth, although we do some neural architecture search. But basically like enabling them with, in the AutoML setting, we work on other things as well, but in the AutoML setting, people want to tune the hyperparameters, the learning rates, the batch sizes, maybe like change the training configuration to make it more efficient, run on fewer GPUs. And so those are kind of like typical black box problems. And so this is like the level at which we work with them and say like, hey, here's BoTorch or Axe, and we have other abstractions. We have a tool called Axe Sweep internally, which is basically an integration of our tooling into the internal backend kind of like ML training infrastructure at Meta. And so that's typically how we're getting used through like a couple of levels of indirection.
Okay, yeah. And so I'm curious then, how does that work for the, like, your stakeholders seem to be very technical then, right? You mainly do you mainly interact with these people who run the model, like who write and run the models, and also do you talk to non-technical people, or do you mainly interact with the technical people who will run the models, and these ones are going to talk to the business, for instance?
It's a mix of both, right? So, if it's a more of a deep dive and we go into like actual methods development, then very much with like the ML engineers I think on the ground, right? Often then we have basically relationships with some of the tech leads who have been around and have like a more global view of the product org, of kind of like the ML org in that branch. But there's also, basically, ultimately, there's a lot of things out there, and people have like very limited bandwidth, right? And so like putting a tool out there, makes it so like not guaranteed that it gets used. So basically, you have to. There's a decent amount of sort of like, oh, we need to have some kind of like program or proposal to test this out and like bake this into some process, right? There's some run books that say, oh, you should use that rather than, I don't know, eyeballing it or doing grid search, right? And it, I don't, basically people have a lot of things to worry about, and so we want to guide the process in a way at the organizational level that they're using kind of like the most effective tools, and that also requires like talking to, product managers or like technical program managers to figure out like how do we bring the most effective methods and tooling into kind of like the overall flow. So there's a lot of kind of like non-technical aspects about process design, reliability, incentives. So it's kind of interesting to feel like often these are like more challenging problems than like solving a particular technical problem.
Yeah. I mean, that's why I ask you also these, because this clearly part of the job. It's let's say a less mathematically technical part of the job. So I'm always also interested in that one. And I mean, and obviously something I talk a lot on the show and love asking is how do you communicate uncertainty and guardrails to the different stakeholders? Because in my experience, that's really something that's very important, because you as the developer knows really your methods, not necessarily perfectly, but usually much better than the people who are gonna then use your product. So how do you do that? How do you manage that without overwhelming them? And also, how does that help you gain their trust?
Yeah, that's a good question. I mean, I guess there's like, if you say uncertainty, I'm thinking of two things, right? Like there's one, how well will this tool work, right? And which problems will it work well on? And then there's like the more specific kind of uncertainty about like, hey, we have like a posterior prediction, and like here's your predictive variance of our estimate for what you can do with this. I think on the latter, people generally have taken statistics courses, so they're not kind of like deer in headlights when you confront them with like a variance. But certainly it's very heterogeneous in terms of the understanding. And there it's just kind of like trying to be, when we like show we have visualizations of like plots, be very clear about what, these confidence intervals represent, and just be very clear and have intuitive explanations, so people can like grasp it at a high level, and then like double click and go in to understand the technical details. So that's kind of like the kind of like more specific like uncertainty quantification part. Regarding uncertainty and guardrails, I'm not sure about guardrails, but uncertainty, like how well will this work, right? I mean, typically it's going through. It's often an empirical. Well, it's part kind of like intuition, part empirical, right? Like people who have worked in this area for a while and have run a lot of these kind of like problems with different applications, different product teams, will have like a good sense for like what will likely work and like what will not work, right? Like if there's like very much like weird noise distributions and millions of data points, and people want us to fit some model, it's like, oh, like this is like probably risky business, and if you want to do that, it's going to be a lot of time. But if somebody just has like a pretty standard black box problem, oh yeah, this will work, So that intuition kind of like allows us to prioritize, what problems and what kind of collaborations should we focus on. And then the rest is like empirical, right? Like, we work pretty closely on a couple of proofs of concepts. We'll run this, and if it seems to be working as intended, we'll run some more and like maybe like test it a little bit more and figure out what are the edge cases. And then that allows us to kind of like build a trust, incrementally, and then from there we can go to productionize kind of like a particular application. Of course, it helps to have a lot of papers on the subject and like be known in the external community. That's like a type of external validation, so people like have some trust from that. But of course, there's this is just research, but that's not the sentiment. But you could say like, oh, this is just research. How does this actually translate to my problem? But we do have a track record of doing this internally on various problems, and so just having that visibility and having that trust built up over time.
Yeah, that makes sense for sure. And the one of the things I'm always very curious about, because what I loved is that you do so many things and you have now a lot of experience. But what I'm curious about is, do you have, without breaching any NDAs, can you remember a memorable misstep in translating a paper idea to production and the process changes that it prompted?
So yeah, I guess, do you mean like in terms of like breaking things, or in terms of like the research not working out kind of like as intended?
Oh yeah, actually I meant the first one, but I think the second one is even more interesting. So yeah, let's do that.
Yeah, I can talk about both things, right? So in terms of breaking things, maybe I'll go into that first, and then I'll go to the second one. And so I guess like that, regarding the process, like usually it doesn't like get that far, I guess is the short answer, right? Every complex piece of software, will have bugs that you introduce during the development. Everybody knows that. Fortunately, as I mentioned earlier, like, the algorithms that we have don't like serve user traffic directly. So if, a bug that gets in doesn't make it directly into like breaking quote unquote prod in the sense of, taking down Facebook or Instagram. So we're a little bit isolated there. It can affect various layers of other infra that is being used on top of that, like, the training jobs that the ML models, get trained on that serve the actual traffic. So we do have to be careful with what we ship, but there's a lot of layers of safety in place. And so these things typically get caught before they're causing like big issues, and we have an on-call to help fix that. Or like, it's usually also not like new paper ideas that cause these sort of like production issues, right? There's a lot of prototyping, testing, and evaluating things if we see a new idea, or if we have a new idea for a model or an acquisition function, say. So that, like goes through some process, and like usually, this is going to be run in some notebook and, more exploratory. And then we have a benchmark suite, so we run that. And so usually we'll run into, issues or mishaps there earlier. It's usually more the mundane things that end up breaking things, right? There might be some subtle change in some library that we depend on that changes the behavior of the algorithm in some way that's like unforeseen and not covered by some test. And, then we spot that, and hopefully spot it soon, and we'll fix it, we'll add a test and avoid that in the future. In terms of like, what ideas out there that, in terms of research ideas that just end up not working, I mean, I don't have a specific example for that, but I guess what I would say is like, I mentioned this sort of like pipeline where we see, hey, this is something that could be useful for one of the problems we're working on, have somebody dig into it, maybe with somebody else, give some talks of what the findings are, and we'll basically do more ad hoc exploration of that. And often some things that are in papers out there will work well in a particular setting, but not well in another setting. I mean, there's like one example that I have is like we worked on hierarchical search spaces, right? Like where your optimization domain has a certain hierarchy to it, right? Where you basically say, oh, if I add on this module for an ML model, and then I have these hyperparameters, but if I use another model at different types of hyperparameters. So this kind of like hierarchical structure of your optimization space. There are some papers out there that look good on paper, quote unquote, but then don't necessarily translate to some internal. So that's one example of things where we investigated and where we found that, okay, this is like actually harder on these problems that we're facing internally than the paper may have made it seem.
Yeah. Actually, talking about papers, now, preparing for the show, I saw that there are dozens of papers which extend BoTorch or PyTorch. So I'm wondering, as the developers, how do you decide which external contributions you add into the main package? And yeah, basically what you're trying to optimize for in the main package.
Yeah. So, I mean, I guess I don't think there's thousands of BoTorch papers, but there is a decent amount. PyTorch, of course, has a ridiculous amount of follow-up work on that. So there's a lot of great research out there, even for Bayesian optimization and things that are more proximal to like the specifics that we do. It's too much to kind of like evaluate in detail for us for all of it. We can't just like we would spending all our time basically reviewing those papers and testing them out. So our MO, I would say, is usually more, we're coming from the applied side, right? And say like, okay, what are the kind of applied problems that we need to solve, and what kind of work that's out there could help with that. And then, we go deep on that. And if it turns out to be valuable, we dig a little bit more, see what we can improve, and maybe add it, to BoTorch. And other than that, we really, rely on the community. So there's been a lot of like high quality contributions to BoTorch from other researchers, which has been really great. And it was one of the things we discussed earlier, the benefits of open source. So we really value that, and we'll be very supportive, and we'll invest, actually a lot of effort in reviewing PRs and providing detailed feedbacks to people who want to do that. Our quality standards are quite high, just we are running the stuff internally. So it is quite a bit of work to put, like your standard research grade implementation into BoTorch proper. We did add a BoTorch community module recently, though, where we're a little bit more lenient on the requirements, I'd say, so to make it less scary for people to contribute. So if you are out there and want to try that out, you can give that a shot.
Yeah, I mean, that definitely resonates with my experience mainly on PyMC, where it's one thing to have something experimental that works with PyMC, and it's a whole other thing to add it to the main package, because then you have a lot of other things around that have to work so that it doesn't break anything in the package that's used by hundreds of thousands of people out there. So yeah, it's always a balancing act. I completely get what you mean here. And actually, so talking about contributions, I'm wondering if you could add one magical quote unquote capability to BoTorch that would most accelerate both the research and the production adoption of it. What would it be and why?
Yeah. So typically there's kind of like actually like a tension between like the research and the production side, right? Research means you want it to be quick, modular, like you can hack things in, which is like not what you want for reliable like production use, right? And so it's kind of hard to. So if you find something that like does really well for both research and production, then I would actually say like this would really be magical, right? But what are the things that I think it would be great to have? So obviously, LLMs, foundational models are a very big thing, and I do think there's a big opportunity to leverage, the vast amounts of knowledge that are distilled into those models in ABO or Bayesian optimization setup as well. So there's a lot of research that's being done on that. We're also doing some of it, and I do think there's a lot of interesting things out there. I don't think things have converged on like the right way to do this yet. So I'd say like having an elegant way of integrating general LLMs and augmenting the optimization with some strong priors now in the form of the foundational knowledge that's in these, LLMs. That would be really great. And I think having that could make, so like few shot optimization where you only need a few observations rather than running kind of like a larger set of trials to have like a model fit on a bunch of data could really make that more of like a technology than an art, which I think what it still is today.
Okay, yeah. Yeah, that makes sense. And since you mentioned LM, I actually can't believe that we managed to to do almost a whole show without talking much about transformers and LLMs. These days, it sounds impossible. But yeah, now that we're talking about them, I'm curious. A very practical question, because we have a lot of practitioners in the audience, and you are literally at the epicenter of that research and development. You guys now have the super intelligence lab. So I'm curious, personally, or even in your team, how do you guys integrate working with LLMs in your code? How do you manage that? How do you balance having some stuff done by the LLMs and then having the humans in the loop? What would you recommend as good practices if you have any? Very curious about that.
Yeah, so integrating LLMs in the code. I mean, there's like the whole other side of like using LLMs as kind of like, knowledge bases and agents. I mean, obviously a lot of like, organizations will fine tune foundational models, and then you have a chatbot that can tell you how to set up a BoTorch problem, right? That's great, but that's not necessarily kind of like what we do. So I think, I don't know if I can have like a list of best practices. I think they're being like developed right now. I think it's still pretty, there's something out there, but I think people still figuring out what the right setup is. I do think that one thing that we've been working on recently, which is I think quite exciting, is using LLMs as a way of making it easier to incorporate human knowledge in the optimization. So you can have prior knowledge of a problem and say like, oh, I think the optimum in the search space is here, or I think like, oh, the model is probably monotonic, right? Or there's a periodicity to this setup, right? Because there's some kind of like seasonality in the time series. These things, if you have that prior knowledge and if you put those inductive biases in your model, right, that helps a lot. But the standard kind of like ML engineer or even just kind of like a product person, right, who doesn't necessarily do a whole bunch of like deep engineering, they may have that intuition, but like they're not going to go and write down like a GPyTorch subclass and like implement the periodic kernel and stick that in, right? It's just really hard to like integrate that. And so I think that's where LLMs providing like a natural language interface for people to interact with the problem could really help. So like, hey, tell me what you know about the problem, right? And then maybe have some kind of automated chat with people, and then extracting from that some kind of information in some kind of embedding latent space that allows us to then combine that with like the optimization that we're doing. So again, like this is early days. We have some projects on that. But I think at a high level, I think that's what I'm excited about, right? Because there is a lot of knowledge that people have that isn't necessarily written down anywhere, right? People who've like done a lot of product work, it's maybe kind of like distributed in different posts on different different surfaces. But if you ask somebody, they can usually give you a decent idea of what they think about the problem. And finding a way to incorporate that in a way that is just a language interface, I think, is exciting.
Mm-hmm, mm-hmm. Yeah. Like so something like an LLM assisted modeling workflow in a way, where
Yeah, exactly. Yeah, so basically, is it, do you think it's monotonic, or like this is like one aspect about the prior, but also like the preferences, right? Like the preferences of the user, what they want to optimize, is another one. So we've done preference learning for quite a while on the team. So the idea is basically like, if you have a very specific problem, you want to like, I don't know, minimize the loss of some training job. Sure, like that's not hard. You minimize the loss and then you optimize the hyperparameters to target minimizing that loss. But like often when we do parameter tuning for online applications, the folks we work with, they have like 20 different metrics that they care about, right? And they can't write down what their objective is, right? They're gonna look at like 20 metrics and say like, this looks good, this doesn't look good. And maybe they'll say you like, hey, this is good because this metric is good, but they can't like write down a utility function. And so learning from like decisions or preferences with like say pairwise comparisons is something that we've done for a while. That's not super data efficient, right? Because you have to ask them a lot of questions. Which do you prefer, A, B, or C, or like rank, these five or whatever. But I do think that, again, the LLM aspect, maybe, we can encode from more free-form feedback about, a particular outcome, what people's preferences are, right? Like they would say like, oh, I think this is a great like setting because this engagement metric is up, but like, and it controls this like other counter metric, and like, oh, the capacity used for this is low. And so there's a lot more information in this kind of like free-form feedback. And if we can distill that from like human in the loop setup, I think that'd be very powerful. And we are working on some of these aspects.
Yeah, well, definitely need to come back on the show once you have something on that, because that sounds super exciting. I'm definitely down to try the beta version. Let me know. Awesome. Well, Max, that was really, really awesome. I still have a lot of questions, but I'm gonna need to let you go because you've already been very generous with your time, and I don't want to have a 3-hour episode.
Yeah.
So let's call it a show. But before that, of course, I'm gonna ask you the last 2 questions. I ask every guest at the end of the show. So first one, if you had unlimited time and resources, which problem would you try to solve?
Yeah, it's a pretty deep question. I mean, I think, collectively, in the sense of like humans, we're actually like amazingly capable of solving hard problems. If we take a reason and science-based approach. I think that's becoming harder. It's not really on vogue anymore, right? Like societies are becoming like so divided that it's becoming really hard to have arguments based on facts and reasons. Right? It's kind of like who yells the loudest or has the most extreme views kind of like gets heard. It's not a commentary specific on the U.S., by the way. I mean, I think that's a trend in many societies. And so I guess like solving that issue, right? Like getting people back to have like a more reason and science-based arguments. I feel like you could empower humanity to really like turbocharge problem solving and actually like crowdsource solutions for many things, right? So I think that is like one of the big things that is an issue for society, and I'd really like to, if one could solve that, that'd be great. Or we could do something simpler. We could like cure cancer, or like avoid the inevitable heat death of the universe, or do anything else that's easier than that.
Yeah, I definitely resonate with that. Yeah, I love it. Basically, yeah, kind of how to teach epistemology in an efficient way is yeah, like I completely agree with you, and I think that's one of the answers. I think that that's the answer I gave when I had to answer that question myself.
Okay.
And yeah, it was something very similar. So we can team up if you want, Max, and then not solve it together.
Great. Yeah. I will not take you up on that. Yes.
Yeah, but no, seriously, I think it's indeed a very, very interesting question, and in some ways a depressing one, and in some other ways one that is very very helpful. So it's like it's a weird question, but definitely a worthwhile endeavor if we had unlimited time and resources. I really agree. And second and last question: if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Yeah, I think I'd go with Leonardo da Vinci probably. I'm really like intrigued by this figure of like the Renaissance man, right? Who's just so skilled at so many different things and also so interested in so many different things. Arts, engineering, science, and Leonardo da Vinci is kind of like an archetype for this. So yeah, I think that would be really interesting just to like peek into someone's mind who's kind of like just has such broad interests and such broad skills. Also, he's Italian, right? I mean, the French are trying to claim part of him, but given that he's Italian, I'm sure the dinner would be delicious.
Yeah, that makes sense. Yeah, I didn't know French people were trying to claim he was. No,
Because he spent the last he spent the last 3-4 years of his life in France.
Yeah, he died in France, but that doesn't make you French.
I think there was some like some discussion about like some exhibition in the Louvre about him, and then there was all kinds of like politics around that. But anyway.
Interesting. So that gives that gets us back to the answer to the first question. But yeah, actually, if you haven't have you visited the Clos Lucé, which is Leonardo da Vinci's last house?
I have not, no. But I will be in Italy in 3 weeks.
Oh, okay. So, hope you enjoy. I'm sure you will, because Italy, you can't go wrong with Italy. But actually, Clos Lucé is in France.
I know. Yeah, it's outside of Paris. Yeah, I know.
Yeah, it's close to my hometown, so I've visited it quite a bunch. Really, really recommend it. It's absolutely beautiful. It's in a small town called Amboise, and to me it's actually better than the castle, because there is a castle of Amboise, which is really beautiful, but actually I much prefer the Clos Lucé when I go there, because they have a lot of artifacts from Da Vinci, even some writings from him, which are always very esoteric, because he was writing from right to left, and also some models of his inventions, like the tank or the plane and the parachute and so on. And the garden is absolutely beautiful. There is even still the vines that he had, because he planted some vines to have some wine. So they are still there in the same soil. So definitely recommend. It's a great visit, and helps you connect a bit with Da Vinci. Not as much as having dinner with him, but that will help a bit.
Cool. Well, I didn't know I was going to get travel advice on this, but thanks. Yeah, I'll check it out when I'm in the area.
Yeah, definitely recommend. And it's not too touristic, so I guess it will be now that I mentioned it on the podcast, since millions of people listen to that. But that's my fault.
Yeah, it's a first world problem, I guess.
Awesome. Well, Max, thank you so much for being on the show. That was a blast, and not kidding. Like next time you have something that you guys release, especially open source, let me know, and I'll be very happy to have you back on the show. A big thank you actually to Gabriel. Gabriel, I'm gonna butcher your last name, but Stechholte, who recommended me to contacted you, Max. Also Andres Arpas, who is a colleague of yours at Meta. Both of them were really recommending me to have you on the show. I butchered both of their names, so but thank you so much, guys, for the recommendations, and thank you so much, Max, for taking the time and being on this show.
Yeah, thanks, Alex. It was great. Had a great time. And I should also thank folks that made this possible, which is my team at Meta. I can't name them all, but the adaptive experimentation team who make BoTorch and all the work we do possible.
Yeah, definitely. And you guys make a tremendous work, and thank you so much for doing that and open source all of that. That's definitely super appreciated.
Great. Thanks, Alex.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher. and visit learnbasedstats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbasedstats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Loss and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbasedstats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.